In today's video, we're going to take a look at the N100 platform, in this case a motherboard by Asus and some RAM, and we're going to talk about some servers today. Alright, before we get into the nitty-gritty with the N100 motherboard and doing some testing with it, let's take a look at some backstory first. This is the current situation of what is my home lab, essentially. From top to bottom, we have a patch panel, we have a unified 24 enterprise switch with 12 1GB, 12 2.5 gigabit and two 10 gigabit SFP Plus ports. I used to have both of the SFP Pluses occupied, but due to some unforeseen circumstances, this dual 10 gig port or NIC actually decided to no longer work, and the reason is this here. This card will disable itself in firmware once it detects a fan failure, and I didn't have time to actually source a new compatible fan or combine some other fan with this particular header, so it's now running at 2.5 gig, but that's fine for now. Below that we have the main server for our home network. It's titled HV01 because it's running Hyper-V and it's the first server. It's based around a 10th gen Intel Core i5-10600 on an H510 ITX motherboard with an NVMe SSD for boot, two 8TB hard drives for storage for the Plex library, and another internal SSD that hosts some other stuff. It's using shared storage to actually run the VMs on. That's the bottom server right there. That is a Proxmox host that has a virtual Exponology install on it, and that's running quite well with four 6TB hard drives and two 2TB SSDs. It also has a 240 gig NVMe for caching for the hard drives, and that's been working good enough-ish, except for the fact that network card died. But anyway, the server in the middle there is a test server. It's usually turned off. It has a Ryzen 5 5600G, 32 gigs of RAM, just like the other two servers have, and two 2TB SSDs. It has no hard drives, just SSD storage. So with that out of the way, the actual home server, the HV01, is the main target of today's video. I will be replacing, or at least I'm looking to replace, the 10th gen Intel Core i5 with the new Intel N100. Because power is pretty expensive these days, at least here in mainland Europe, and for that reason I'm looking to downsize a little bit. I don't need the peak performance that the Intel i5 can give me, and the N100 should be fast enough overall to basically take up all the other tasks that it needs to do without actually having a issue. And yeah, TDP difference is of course quite stark. The 10600 is, I believe, somewhere in the neighborhood of 70 watts. I'll put a correction on the display if I'm wrong, doing this from the top of my head. And the Intel N100 has a total TDP of 6 watts. So yeah, in pure idle mode it shouldn't make that much of a difference, but the host is usually doing something, and especially when it's going to try and transcode some video, which you will need the onboard graphics for, which are a bit faster on the N100, then that should save some power. And if I really like the N100 platform, I am actually looking to replace the motherboard down there as well in the NAS. Granted, I can find some nice additions to the motherboard that we'll go over shortly on the N100 board that we have in the video today. So that's a bit of a backstory. Let's get back to the motherboard and see what we get. Alright, so here we go. Here we have the motherboard that we've chosen. It is the Asus Prime N100I-D D4. It's a mini ITX mainboard featuring the N100 chip, which by the way is a 12th gen Intel Alder Lake based CPU that only has 4 E-cores. Turbo up to 3.4 GHz, quad core, 6 watt TDP, so very nice and efficient mainboard. Haven't opened this up yet, so we're going to experience this together. Inside we find the mainboard, obviously. Very nice and compact. CPU is integrated, so we only have a heatsink. And here we have some accessories. I'll just get all of those out, see if there's anything interesting in here. Not really, okay. just your regular booklets and whatnot. I am a tech channel, I do not need to read instructions. That's of course very arrogant to say, but yeah. Obviously sometimes we need to RTFM because some stuff is just not as obvious. Right, so here we have some screws. I believe this is an M.2 standoff in its back with an accompanying screw, and here's just a screw. So one of the M.2 ports on this motherboard should have a standoff in place from the get-go. I'm guessing the Wi-Fi slot does. User guide, which we'll need to figure out what we need to do in terms of headers, but that's not really that relevant for our test setup today, because we'll only be running a test. We will not be actually building anything, because I'm still waiting for 2 parts from AliExpress, namely a converter for the Wi-Fi M.2 slot to a RJ45 2.5 gigabit controller. That should arrive somewhere, I think maybe end of this month, early December. So that's what we're going with. And we get to SATA cables and the I/O shield as well. Put all that to the side and take a look at the main board. The case I'm using is an Intertech 1.5U case that only accepts mini ITX motherboards. So we had to go with mini ITX, which I'm fine with, nice and compact. And of course we have some memory as well. This is a 32 gigabyte module from Kingston. We only have one SODIMM slot. We'll go over that in a little bit. Okay, so here we have the main board. It's black on black and it's a little bit dark. So I'll hold it up like this. On the top we have the SODIMM slot. We have a fan header over there, USB 3 header over here, ATX power here. That's also one thing. Some of these N100 boards have a DC barrel jack. I prefer not to use those. I want a regular power supply. I've already invested in one in that particular system, a 350 watt Flex ATX Gold by Silverstone. And I really want to keep using that because that thing was expensive. Right, anyway. CPU 4-pin because it only uses 4 or 6 watts. On this side, I think this is the audio header, and this is USB 2. Here you have NVMe slot, or the M.2 for an NVMe SSD. We do in fact have a standoff there, that's good. Or do we? No, not really, but there's a place to put one. We do in fact have the standoff for the M.2 Wi-Fi slot, which we will be, we won't be using today, but we will in the future for a 2.5 gigabit breakout. So we can use Ethernet, because I do not intend to use Wi-Fi. It is a server duty that's destined for this board. So yeah. Here we have a COM header for a serial port. We'll get over or talk about it in a little bit. Printer header. So this is definitely for a legacy industrial type of deal. One SATA port, which is interesting because we have 2 SATA cables, but only have 1 SATA port. That's also one of the things that I'll be putting in this PCIe X1 slot. We will be using this one for a SATA expansion card, so we can run the hard drives. They'll mainly run off that controller. We'll use this for the internal SSD that's already in there for some random storage, and the NVMe will just plop that over from the original board. So there's that. Anything else to note on this board? From what I can see, not really. No, just front panel headers and that's it. It's not a terribly expansive board, nor is it expensive, if you know what I mean. It's $100, around about there. I bought it for 100 euros because I'm in mainland Europe. And if you take a look at the I/O on the back of the main board, we have PS2, dual USB 3, again USB 3 here as well. We have gigabit LAN. This is a Realtek controller. 2 USB 2 ports, display port, HDMI, VGA, serial, and onboard audio, which we will disable. And again, under this heatsink is the Intel N100 SoC. Okay, I guess we're ready for our first test boot. I've just completed the test setup. First I wanted to use a SATA SSD, but I found another NVMe in my stash, so we're going to use that instead. This board obviously does not have a fan, We could add one to see if it spins, but I guess we'll have to find out how to make this thing work. Let's seeing a terrible lot happening. I guess we'll add a fan so we can actually see if it starts up or not. This power supply also does not always have a fan spin, so be right back. Okay, we have our sign of life fan. Let's see again, power button. That's very loud for a passive system, isn't it? Okay, let's see if it posts. The reason I'm questioning that is because, quite frankly, Asus lists a maximum of 16 gigabytes of RAM for this motherboard. And they do not support 32 gigs at all, they said. But judging from what we see here in our DisplayPort driven display, is that we indeed see 2666 megahertz memory, or mega transfers rather. It's actually running at 1333 megahertz, but that's beside the point. Running at a base frequency 800 megahertz, Intel N100 CPU. BIOS build date from 14th of June 2023. Very old school BIOS here. Let's see what else we can find. Platform configuration. All kinds of power management features here. Virtualization, yep, we need that because we will be running a Hyper-V on this as well. We're just going to swap over the SSD once we make it go into production. We can choose turbo or non-turbo performance or battery. We do not have a battery. This is a desktop. System agent VTD is enabled. I'll actually want IOMMU on as well, just in case we need to pass through some components and figure some stuff out there. 64 megs fine. M.2 is running at 2x. And our X1 is not present. Okay, good. SATA controllers enabled. Yep, we want to keep that enabled. We can enable hot plug on the SATA port if we want to. I don't think I will because it's not in a hot swap location, that SSD that we'll be using in that slot. Firmware TPM is okay. SRIOV, yep, want that as well. Okay, we don't really need handoff, but it's fine. 240 gig Kingston, yep. Checks out, properly detected. You can see smart values for the internal port. We'll disable audio. For now, we'll enable the onboard LAN controller. And we will definitely need to leave this enabled once we get the adapter from AliExpress. That's something we'll look at in the next video. We will not be using the serial or parallel controller, so we'll disable those. We don't need to have anything turned on that we won't need. So looking fine. This is a good power supply, known good. Comes from my gaming PC, 550 watt gold. Won't be using this obviously in the system, but it's good enough for now. Can do some fan tuning there. CSM is disabled, good. You don't need that. We will set this to Windows because we'll be running Windows on this. BIOS image rollback, yep. We can also run Easy Flash from here to update to the latest BIOS version. We'll do that later. Right, our bootable USB is done, so we can see we can install an operating system on this. Find a USB 3 port. If I actually would end up installing a new BIOS, if there even is one, then I'll do that later. For now, we need to figure out if it's stable the way it is, and if it can even run Windows Server 2022 without too much issues. So that's what we're going to find out next. I'm happy that 32 gigs of RAM is working. Doing a double post again. Press F8 on Asus motherboards. There we go. SanDisk. And there we go. Alright, I'm going to install Windows Server, and I'll get back to you once it's done so we can see how it runs. And here we are at the Windows Server desktop. As you might have noticed, it's gotten a bit darker, and that's not because I've been tinkering with this for a whole day, it's just because the weather is absolutely terrible. And yeah, it's been about 45 minutes since the last clip. I've successfully installed the operating system, installed all of the updates, installed the Hyper-V role, installed all the drivers, aside from one that I couldn't quite track down yet, but that's fine. Everything else is working great. So yeah, here we have CPU-Z open. I'll zoom in for you. As we can see, we have an Intel N100 chip, Alder Lake 6-watt TDP, 10nm architecture, and it's hovering somewhere between 400 MHz and 3.4 GHz. We have 6 MB of L3 cache, 2 MB of L2, 4 cores, 4 threads. So if it's not doing anything, it's going all the way down to 400 MHz, barely consuming a watt. Here are some more information. We have 8 gigatransfers per second PCI Express, while these CPUs only have 8 or 10 lanes, if I'm not mistaken, so there's not a whole lot to go around, but it's fine. We have our 32 GB of RAM detected at CL19, which is correct. 1 slot, 1 module, and it's running rather well. Graphics is of course the built-in Intel UHD graphics, which will boost up to 750 MHz. Yeah, that's definitely some power there. What we can do here is run a little bit of a short benchmark hop. Let's go with a multi-thread, use all 4 threads, and go for bench CPU. See what we boost up to. Alright, we have 1300 multi-thread. Single thread 377. Okay. Let's do a comparison here. See how far we can go back. Something that would be comparable, I assume, would be something like an 8700K. Alright. Not quite as fast as that. Compares reasonably to a Ryzen 1600. 7600K is also about on the money. Much faster than 7850K, obviously. And a Core 2 Duo. Yeah, this is a bit more interesting one. A 4-core 8-thread. 2600K. That's a 95-watt CPU. Keep that in mind. This is 6 watts. And in terms of single thread, we're a bit faster. And in terms of multi-thread, we're a bit slower. Also compares well to an FX 8350. 6700K, yeah. all looks about right to me. So in terms of single thread, it's reasonably up there with the modern CPUs. And in multi-thread, it's a bit slower, but then again, we only have 4 cores and 4 threads, so there's not that much power to work with in the first place. But it's all about efficiency, and that's what we're going for. I think it'll do nicely. So, in terms of first impressions, I've used the system to install updates and do some basic tasks. It can be a bit sluggish when Windows first boots, but that's to be expected. Then it settles down and it is very responsive indeed. For example, you can load up Edge here, so we can do some web browsing. You can go to Outlook.com and all that jazz. Does just fine, as you'd expect. And what I'm here to see is actually how it runs a virtual machine. So what we're going to do, we're going to create a virtual machine using Hyper-V. We'll name it Test, very original, I know. It is a Gen 2 because we'll be installing a Windows Server release that's not quite out yet. It's one of the preview versions for Server 2025. We'll give it 8 gigs of RAM, connect it to our gigabit controller here, give it a 60 gigabyte disk, use a bootable image file, which we have stored on the C drive, as we can see here. See what I did there? Right. Inside our preview. Finish. If I've set up the BIOS correctly and it supports all the right technologies, this machine should boot. We have secure boot. I think because it's based around Windows 11 rather than Windows 10, this new release, I'm not sure we're going to need the TPM enabled. So we're just gonna wing it. I'm gonna connect to it. And start. There we go. There we go. Hyper-V. Leave everything default. I think it's only giving this thing like 1 core, so that's a bit shabby. Yep, we only have 1 CPU core. And I will correct that after setup, I guess. Doesn't matter what we pick here. In the end, we'll be using a data center license, so we can activate all Windows VMs on this machine with automatic virtual machine activation, which is a very useful feature of Hyper-V. If you're running a Hyper-V server and you have a Windows data center license on that Hyper-V host, you can run all of your Windows VMs down to Windows Server 2012 using an automatic virtual machine activation key. It's much like a KMS key, it's just a universal one you can get from Microsoft. You put it into the VM and it will activate using the host's data center key in the end. And that makes it work. You can only run up to the version that your host is running. So if you're running a Windows Server 2022, the newest version you can activate using that key will be Server 2022. If you're running Server 2019, therefore you cannot activate 2022 VMs on that using AVMA. That's something to keep in mind. But you can install Windows Server 2012 and activate that as well on 2022, even though that operating system is now end of life. Right, but this virtual machine is actually starting and working, so that's all that I needed to know. I'll go ahead, of course, and test this system a little bit more. Once we get the remainder of the parts for this system, we'll give that another quick go and see how 2.5 gigabit works over that Wi-Fi module. I've never tried something like that, so I'm very interested to see how it works and if it even works on this board. And of course, I'll be taking you all along for the ride. That'll be this video for now. Hope you enjoyed it. Thank you all for watching, and I'll see you guys in the next video.